Hello everyone, I'm Inian, and today I'll be talking about Chrome User Experience Report and how you can use this to analyze the real user monitoring data for millions of websites. So yeah, as Perry mentioned, I'm from Singapore, super excited to be here. I run a startup in Singapore called Dexecure. We are building tools to automate various front-end optimization techniques so that you can have a fast-loading website without much effort. I'm interested in web performance and security. By the way, we are looking for developers to join our team, so if you're interested, come talk to me after the talk. And yeah, I'm Ever Confused Guy on Twitter. So let's talk about measuring speed. What are the different techniques that are there to measure the speed of your website? There are two broad techniques. First is called synthetic measurement, and the second is called real user monitoring. So synthetic measurement is where you load the website in a very controlled environment and see how fast the page loads, what's the DOM content loaded time, and so on. And the tools you can use for doing stuff like this is the primary one is webpagetest.org, where you can load the website in different devices and network environments to figure out how fast the website is loading. Real user monitoring, on the other hand, is where you collect data of how fast your website loads in production with your real users. As your website is loading, you can collect metrics like, hey, when did the first hero image appear on the screen, or when did the app become interactive, and so on. Both solve different kinds of questions. So for example, using synthetic measurement, you can figure out if there is a performance regression on your website with every commit. You can even integrate it as part of your CI/CD pipeline. And with real user monitoring data, you might figure out a bug which occurs in a random version of Android in some custom specific device operating system and so on. So HTTP archive is basically synthetic measurement on a much larger scale. So HTTP archive is a project that's been there for quite some time, and it crawls around 500,000 URLs every single month on both desktop and mobile. And it collects a whole set of measurements like what's the onload time. Even collects a lot of different metrics like what's the request bodies for the home pages of the top 500,000 websites. And till now, recently, there hasn't been anything equivalent of HTTP archive for real user monitoring, and that's what Crux is. Crux is Chrome User Experience Report. And yeah, it's basically the real user monitoring data for more than 3.2 million websites. I think this month, the data set has close to 3.8 million websites. It is queryable, very similar to HTTP archive on BigQuery, and it surfaces in other tools like PageSpeed Insights and so on. This data is collected from real users who have opted into data sharing within Google Chrome. And the data is aggregated for different websites. It's not, you don't get per page level data, but it's aggregated over the entire website. So let's see what kind of metrics that you can get from a data set like this. So these are the 4 metrics that are currently available: first paint, first contentful paint or FCP, DOM content loaded, and onload. Take a bit more in-depth look of first contentful paint, because we are going to be using that for the rest of the talk. It's slightly different from first paint, where first paint is where if anything changes on any sort of painting happens on the screen, that's considered as first paint. But as you look in these examples, it may not be really that useful, even if the background color is just changed to white from white before, I guess, the first paint is triggered. So first contentful paint, on the other hand, is a slightly better metric than first paint, is because first contentful paint is triggered when something from the DOM is actually rendered onto the page. So this can be an image, it can be a text, a canvas element, whatever, but it's a slightly better metric for measuring user experience. And these are different dimensions that are available within the Chrome User Experience Report. So all the previous metrics, you can slice and dice with these different dimensions. So one is device, whether the user is coming from a phone, tablet, or desktop, and the effective connection type, which is an API in Chrome, which gives you the network information API. It tells you if the user is expected to be using a 4G connection, 3G connection, offline, and so on. And you can also get the data for users within different countries, where the session was actually collected from, which country it was collected from. So the BigQuery tables, this is one row in the BigQuery table. This is what it looks like. So here you can find out that, hey, for google.com on a 4G connection in a tablet, the first paint for 0 to 200 milliseconds, what is the fraction of users in that bucket? So you don't get raw data points like you do with HTTP archive. You get what is the fraction of users within particular data points. And you also have different tables for different kinds of queries. There's a global table aggregating results for every country, and you can go into country-specific tables as well. I won't be going into the actual queries that we'll be using in the talk. I want to more focus on the kinds of analysis and the kinds of stuff that you can do given this kind of data. So if you want a more in-depth analysis of how to get started on BigQuery, we have written a blog post which gets you to, which tells you the actual queries that we use for most of these kinds of analysis. And because of the way the data is grouped in the Chrome user experience report, we actually found it easier to introduce a new composite metric called site experience benchmark. Because in Chrome user experience report, since it collects user experience metrics like, say, the first paint of a website, you can't ask questions like, hey, what's the first paint of google.com? You can instead ask questions like, what's the first paint of google.com? What fraction of users in google.com had the first paint less than, say, 500 milliseconds? So to answer questions like this, we found it easier to introduce a metric which I'll be using for the rest of the talk called, say, site experience benchmark, which represents the fraction of users which have the time to first contentful paint less than 1 second. So higher the SEB, the better, because higher fraction of users have the first contentful paint completed within the first second. So let's start off with something simple. We all know websites load much slower on mobile devices compared to desktop. So just to give you an idea of how things work, what I did was just took 50 websites of the Chrome user experience report and plotted the SEB metrics for desktop and mobile. Obviously, the SEB for desktop is higher than phone. And you can start quantifying this. So you can say that a site experience benchmark goes down 36% when going from desktop to mobile, which basically means that for a given website at 1 second, 36% fewer users have first contentful paint complete as compared to desktop. So let's move on to more complex questions. So more real-world scenarios, say you're building a new website and you want to figure out if you want to build it as a single-page app or, I don't know, multi-page apps. Basically, single-page apps are apps where you load a lot more of the content upfront, of the code upfront, which has a nice trade-off because the future page loads can be faster, and with traditional or multi-page apps, however you want to call it, the code for that particular page is loaded when actually the user goes to the page. Of course, the distinction becomes quite blurry with like code splitting and preload, prefetch, and so on. But single-page apps, let's keep it as apps which require a lot more code to be loaded up front. So yeah, this is what I did. I, again, took 50 websites, top 50 websites which were using a framework and top 50 websites which were not using a framework. Of course, the sites which were not using a framework had much faster time to first contentful paint. Greater fraction of users had their time to first contentful paint occur within 1 second. And we can actually quantify it by saying that SEB of non-framework websites is 225% higher than websites that you build with a framework. So there are a lot of different criteria that goes on to when you want to decide, hey, should I be using a framework or not? This is just one more data point that you can use in your decision-making process when you start answering questions like this. Again, you can slice and dice the same question with, I just want to focus on desktop users, right? Say, I want for desktop users, is it okay to use a single page app? Because desktop devices are faster, probably I can get away with using a single page app. And as expected, the impact is much more pronounced on mobile devices. So for mobile devices, 486% SEB of non-web framework websites is 486% better than websites with that are using a framework. So a lot more people will see the first contentful paint occur within 1 second on mobile devices for websites without a framework. So yeah, let's answer a few more questions like this to see how you can use Crux data to drive some of the decisions that you might take. Say, suppose you have decided to go ahead with a framework, and now we want to decide which framework to use. Of course, I don't want to start a flame war or anything here, so I'll prefix whatever I say with a lot of conditions, I guess, before, so that no one goes on Twitter and says, hey, React is shit or something like that. But okay, so for this experiment, I'm just going to focus on performance of frameworks, and there are a lot more variables, of course, like, hey, what is your team comfortable with, the support, the ecosystem, and so on, but I'm just going to be focusing on performance. And even within performance, I'm going to be focusing on first contentful paint. There are a lot of different ways in which you can compare different frameworks, right? You can say, if there have like 1,000 DOM nodes, which framework is able to update it the fastest? But for this experiment, we are just going to be focusing on first contentful paint. And traditionally, how you would carry out an experiment like this is like you would build the same website using different frameworks, run it through webpagetester.org, and get the different synthetic measurements for the times, such as like DOM content loaded, on load, whatever it is. So yeah, there have been experiments like done for this already, where people have built like a to-do application or a Hacker News website across these different frameworks, and you can start measuring the performance implications of these different frameworks. There are a few advantages of using Crux to instead using Crux to evaluate the different frameworks. One advantage is that here you are measuring actual websites. You're not looking at a toy application like just a to-do list or like a Hacker News website. Chances are your website is going to be way more complex than these websites. And the second thing is that you get a much more wider perspective on the kinds of devices, the kinds of network conditions, and how these frameworks perform in these different varied environments. There are some disadvantages with using this approach as well. So one of the things is that we are not exactly comparing apples to apples. We are comparing websites which are built with a particular framework with a different website built with a different framework. But I would argue that it's still probably fine, because first contentful paint is an event that gets triggered very early in the page load lifecycle. And we looked at the top 50 websites across, so top 50 React websites, top 50 Vue websites, and so on. So the variability, like the other factors that might influence your time to first contentful paint, are reduced. For example, we can safely assume that all these sites are using a CDN, all these sites are minifying and gzipping their JavaScript, all these sites are not, for example, using a development version of the framework. So it's a good proxy for how fast a web framework is able to perform in different conditions. So this is what we got when we analyzed the top 50 frameworks. You can see that Vue and Preact are pretty much the fastest across the board, followed by React and followed by Ember. And again, we can slice and dice this data from desktop and mobile. We see a very similar trend when we look at SEBs of sites with these different frameworks and compare it. Again, for mobile, we can figure out, we get a very similar trend, but one interesting thing is that see that quite a few Ember sites are having a very low SEB score, which means that these sites, for some reason, do not have a lot of users completing their first contentful paint within a second. Probably might be interesting to dive further into that. So, yeah, so suppose, say, again, one more question that we can answer is like server-side rendering versus client-side rendering. You have decided to use a framework, say React, and we want to see whether you want to employ server-side rendering or not. So traditionally, apps that you build with frameworks are client-side rendered, which means that the server sends a blob of JavaScript to the client, and once the browser receives the JavaScript, it actually generates the HTML that needs to be shown to the user, and then the user sees something on the page. Since the JavaScript needs to be downloaded, parsed, and executed before anything is shown on the page, this can actually lead to a very high time before something is shown on the screen. And server-side rendering is one of the techniques that is used to mitigate this problem in a way. So here what you do is that you execute some of the JavaScript on the server itself, and you send the client the rendered application. So yeah, here what we did is that we took around 20 React websites which were using server-side rendering and 20 React websites which were not using server-side rendering and which are completely rendered on the client side. As expected, the server-side rendering, the apps which are server-side rendered have a much better SEB score compared to the websites which weren't server-side rendered. Again, we can slice and dice the data by desktop, and of course, for mobile, the impact is much higher. So again, using data like this, you can figure out, hey, is it worth investing in server-side rendering? Of course, this adds a bit of complexity to your build pipeline or your workflow, and you might say, I want to just implement server-side rendering just for my mobile devices or only for a certain set of browsers and so on. So this is what we are trying to do at Dexecure as well. We are trying to use real user monitoring data at scale and also per website to drive future performance optimizations. So server-side rendering is, again, not a silver bullet as such. So quite some time ago, Paul Lewis wrote a blog post which compared the loading times and time to interactives for different frameworks. And he actually found out that websites which were doing server-side rendering had a better time to first meaningful paint, but still they had a higher time to first interactive. So this means that server-side rendered apps lock the main thread for much longer than client-side rendered apps. So these are, again, questions that we can answer using, potentially answer using Chrome User Experience Report, where we can measure out, is server-side rendering worth it for me? Is the increase in time to interactive going to offset the time to first paint, for example? Unfortunately, at this point, Crux doesn't give us time to interactive yet, but hopefully they add this metric soon, and we will be able to answer questions like these. Another thing that you can do with Crux is that you can analyze. The first thing that people want to know is, hey, how fast is my competition doing? This is the first time you can indirectly see the real user monitoring data of your competition, right? And you can figure out if my site is loading faster than my competition. And if you are a developer, again, you can write a BigQuery query to get this information. But we found a lot of the non-developers were interested in this question as well. A lot of other stakeholders wanted to know how they are performing. So yeah, this is a site that we built. So this is a site that we built where you can just enter 2 URLs and check how they are performing with respect to different user metrics. Here I'm comparing Amazon.eu and Tesco, and you can see that Amazon is doing really, really well. The dark blue represents the fraction of users which have the onload completed. So you can see like 33% of users have onload completed within just 1 second. And you can see how this varies as time progresses. So this is a good way of like comparing yourself with your competition to see where you need more work compared to your competition. Again, you can slice and dice the data by, say, I just want for phone, and I don't want UK, I want for, say, all countries. And we update this data every time Chrome comes up. So the Crux dataset is updated every month, and we update this data every month as well. It's all open source. I can contribute to it at GitHub repo. And this also helps you set better performance budgets. So if you want a good target to hit while setting the internal performance budgets, you can see, hey, how well is my next best competitor doing? And you can see if he's loading within like 2 seconds, then you should have you can have performance budgets set up with respect to that as well. We also can get insights across the web, very similar to how we can do with HTTP archive. So one of the things that we did is to figure out how if a user is using a 3G or a 4G connection, how much it affects the user experience. So for the same website, say google.co.in, the very fact that you move from a 3G to 4G connection means that 15% of more users would see the first contentful paint happen in a second. But more interesting than this, you can compare 3G with 3G in the sense that 3G is such a broad term it doesn't have a minimum connection speed limit or anything like that. So what 3G means in one country can mean totally different from what 3G actually is on another country. So what we did is we took all the Google's country-specific websites like google.co, google.sg, google.eu, whatever. And then using this, we are able to plot the SEB scores for all these different countries. So the website is the same. We are using the same connection type, but still you can see that the SEB scores vary so widely even within the same connection type and relatively same website. So you can find out statistics like, hey, SEB of Google in Venezuela is 30% lower than the SEB of Google in Sweden for the same connection type. And you can get similar insights for 4G connections as well. And yeah, we got something like SEB of Google in Nigeria is 25% lower than Sweden for 4G connections. Another interesting thing that we did is comparing the global website with country-specific websites. So different brands and different companies have different websites targeted against a particular country so that they can personalize the content, the currency, language, and so on. And hopefully the country-specific website is faster than the global website. If I am, say, in Singapore, I hope that google.com.sg, which is the default website that I'm redirected to, is faster than google.com for users within Singapore. So we were able to measure that for Amazon. So for the 13 sites that we tested, 12 of them had better SEB metrics for the country-specific website, which is what we expected. So on an average, we found that by using the country-specific website, you get 18% higher SEB for the same website. We also did the same study for Google. Google, we analyzed 162 domains. And for 26 of them, we found that using the global website, using google.com was faster than using the country-specific website. I'm not exactly sure why the reason is, and we actually plotted which countries this anomaly happens, where instead of probably users in this region should visit google.com instead of going to the country-specific website. It seems to be that countries in South America, some countries in Africa, and in the Middle East, this problem seems to happen. Probably someone from Google can figure out why this is happening. And we actually found a huge discrepancy for the Google's China website. So we found that if you are within China, accessing google.com is 40% faster than the corresponding Google's China website, which is google.cn. I'm not exactly sure, again, why that happens. So some gotchas when working with a data set like Chrome User Experience Report. One, the data is aggregated across your entire domain. So if you have one really popular website, if you have a really popular page which is behaving badly in terms of performance, that can affect the metrics that you see in Crux. We also need to be careful while analyzing the HTTP and HTTPS versions of a website. Sometimes Crux has data for both, and hopefully you're just doing a redirect from HTTP to HTTPS if someone visits that. The thing is, Crux considers that itself as a page load. So it just, if you look at the data for, say, Flipkart.com, you'll get 99% of the users have their page downloaded within a second. Of course, that's just being the redirect, I assume. Another thing that makes it sometimes hard to analyze across websites, across different websites, is that you really don't know how many data points are there for each website. Probably for the Google China example that we saw, there are very few data points, and that's why the data was a bit skewed. So Crux just gives you the density of data in each bucket. It doesn't tell you the number of data points. And even though this is real user monitoring, you need to be careful that this represents data coming from Google Chrome browsers only. So any insight that you gain from Crux, you need to take it with a grain of salt. Chrome doesn't equal to the web. That's it. You can check us out at dexsecure.com, and I'm Ever Confused Guy at Twitter. Thank you.